Right, grade 11s, we're on to our topic 2, which is our first type of pattern that we're going to do, which is something called linear, or we call it arithmetic. Now in matric, we're pretty much only going to call it arithmetic, but both of them are the same pattern. Now, there's a reason why they call it arithmetic, and then there's a reason why they call it linear, and I'll explain that as we go along. Now, everything in this video that I say should pretty much be revision from grade 10. So there's going to be 9 examples, and we probably get to them quite quickly because we're just practicing grade 10 and also kind of fine-tuning our notation and our understanding of notation before we start our new stuff. Okay, so why are these patterns called linear patterns? And the reason why they're called linear patterns is because if you graph them, you would get a straight line. So if you had a sequence that is a linear pattern, it lands up forming dots that form a straight line. Hence it's called linear. Now the important thing to remember with linear is any linear graph has the equation y equals mx plus c, which means that in this case we're not working with x's and y's, we're working with tn and n, but you'll notice in my first example there's an n in the equation. So there's no n squared because that would be a quadratic function, so that would be a parabola. This is a straight line, so there's there's no n squared. So that's why it's called linear. Why it's called arithmetic, we'll get to that in example 1. So example 1 says, if the general term, remember general term or general formula is the formula, the Tn formula that can predict the whole sequence. So if the general term of a linear pattern is Tn equals negative 2n plus 1, so that means the value of any term in the nth position has this equation. So it says write down the first 5 terms of the sequence. So this is just practicing notation. So what would T1 be? T1 would be negative 2 times 1 plus 1, which would be negative 1. T2, so the value of the term in the second position, would be negative 2 times 2 plus 1, which would be negative 3. The value of the term in the third position, and you could go on forever because you're basically just changing the value of n. So that's negative 5. The value of the term in the fourth position, negative 2 times 4 plus 1, negative 7. Now I'm hoping that you are seeing a pattern because that's the point of this example. This is negative 9. So those are the values of the first 5 terms. So if I wrote this out as a sequence, the sequence would be negative 1, negative 3, negative 5, and I didn't have to do all that working because once I saw the pattern I could have started predicting the next value. So the next question says, what do you notice about the sequence? And I'm hoping that you notice that every single time to get to the next term I'm subtracting 2. So minus 2, minus 2. Now this is called the first difference. So when you find the difference between the different terms in the sequence, it's called the first difference because you found the difference between these terms. So what we notice about this sequence is it has a common, we say it's a common, which actually means the same or constant first difference. So basically every single time here we're subtracting 2. So we have a common or constant first difference. Now that's why these patterns are called arithmetic, because arithmetic means to add something. So we are basically adding negative 2 every time here. Now your difference can be positive or negative. There's no rules about it only being positive. So we could be adding 2 every time. In this case we are subtracting 2 every time. But most importantly, linear or arithmetic functions patterns always have a constant first difference. So that's how you tell if something is linear or arithmetic, same thing. Always has a constant first difference. So the most important thing in any patterns question is to figure out what pattern are you working with. And so if you're working with a linear pattern, you'll see this constant first difference. Now just so you notice, do we see the coefficient of n is negative 2? And my first difference is negative 2. Right, let's go on to our next question. Now our next example is about trying to develop the formula for a linear pattern, which you should have done in grade 10, but we might be a bit rusty. So it says consider the sequence. Now this would be called a linear sequence. First of all, this is T1. T1 in arithmetic patterns always has the symbol A. So A means the first term. This is the second term. Now notice the second term is A plus D. So what have I done to go from the first to the second term? I've added D. This is the third term, and what have I done to go from the second to the third term? I've added another D. So now I have 2 Ds. How do I go to term number 4? I'm adding another D. So this is a linear pattern because it has a constant first difference of D. Now, we always call the first difference, if it's constant, we always call it D. So far we know that A represents the first term and D represents the constant difference. So that's our notation that we're going to use in linear patterns. So it says write down the next 3 terms of this sequence. So the next term would be T number 5, and so what I would do is I would go to the 4th term and I'd add another D. So now I'll have A plus 4D. Then in term number 6 I will add another D, so I will now have 5 Ds. Then in term number 7 I will add another D, so I now have 6 Ds. So basically this leads us to the fact that can we see a pattern? Can we see a way to write the general formula for Tn? Now I'm hoping you notice that the first term was A. Now after that you always added a D. So in the second term you had 1 D. In the third term you add 2 Ds. In the 4th term you had 3 Ds. In the 5th term you had 4 Ds. So I'm hoping that you notice it's always some amount of Ds. Now the question is how many Ds? Now again I hope you notice that it's always 1 less D than the term you're looking for. So I don't want n Ds because the first term didn't have a difference. So you can't have n Ds because otherwise the first term would be A plus 1D, and the first term doesn't have any differences. So it's actually n minus 1D. So let's just quickly write down what all these symbols mean. A stands for the first term. D stands for our constant difference in this linear pattern. Constant difference. And N stands for the position. So if you were finding the value of the first term, you would put in a 1, and you would say 1 minus 1, which would be no D's, which is right because you don't add any D's, it's just A. If you were finding the value of the second term, you would say 2 minus 1D, which is actually 1D, which is exactly what we had. Now this formula is the formula that works for any arithmetic or linear pattern. Now this is on your formula sheet, and so you don't really have to memorize it. You just have to know what does A stand for, what does D stand for, and it's quite helpful to know where this comes from. So let's try and have a look at using this. Example 3 says consider the sequence 3, 7, 11, 15. Now the first thing I need to ask myself is what type of sequence is this? Now in grade 11 we do 2 types of sequences. We've only done 1 so far, and then we're going to do a third kind of type of sequence, and that sometimes it's a weird funny combination, which we'll do in our last video. So my first question is what type of sequence is this? Now in order to answer that question I want to look, is this linear? Well, to go from 3 to 7 I've added 4, to go from 7 to 11 I've added 4, and 11 to 15 I've added 4. So in this case the answer to my question is this is a linear or arithmetic sequence. So it says write down the next 3 terms. Well, that's fairly easy because I've picked up the pattern. So if I add 15 and 4, and then I add another 4, and then I add another 4, those would be the next 3 terms in the sequence. Can I determine an expression for Tn? Well, this is where it's really nice because you don't actually have to think much because we have derived a formula. The formula for any linear pattern is A plus n minus 1D. So Tn in this case, A is the first term, so that's 3, and it's n minus 1 times 4 because our difference is 4. Now there's no need to simplify that. You are welcome to leave it like that. Sometimes people will simplify, in which case you'd have 3 plus 4n minus 4 and so it's 4n take away 1. Now you'll notice, like I said in our first example, do you see that my coefficient is 4? Where did that come from? It came from there, which came from there. So you'll notice that your difference is always your coefficient of n. So there's nothing wrong with leaving your answer there in a test or exam. You can simplify it if you want. Now, I always quickly sub in 1 or 2 n's just to check. So I will put in n as 1 and check, do I get 3? Put in n as 2, check, do I get out 7 when n is 2? Because this is the second term. Now, I think I do, because 4 times 2 would give me 8, and 8 minus 1 is 7. So it's very quick to tell if you're right. Okay, let's try 2 examples like this. First of all, I've got to check, is this arithmetic? Because you never know. So what am I doing each time? I'm subtracting 2, I'm subtracting 2. Therefore, this is a linear or arithmetic sequence. And the moment I know that, I know I have a formula. My formula is a plus n minus 1d. So all I need to do now is fill in what I know. I know a is negative 1, and I know d is negative 2. Now, there's nothing wrong with your constant difference being a negative. The only thing is you've got to remember to put a bracket. If you leave out that bracket, so if you wrote tn equals negative 1 plus n minus 1 minus 2, that means you're no longer multiplying that bracket by the negative 2. And so you have to have a bracket around your negative 2. Now, if you want to multiply that out, you would actually get negative 2n, so negative 2n. Then you get plus 2, take away 1, which is plus 1. But those are equivalent, so you don't have to multiply it out. Again, I would just throw in 1 or 2 n values just to make sure that you're right. Okay, on to the next. Is this arithmetic? Okay, well, what is 3 over 2? 3 over 2 is 1.5. So the difference between 3 over 2 and 0 is 3 over 2, which is 1.5. And now, the problem is the moment we start working with fractions, we start to really be not sure how to, we can't see what this is. So how do I work this out? How do I work out this difference? Do we notice that if we say, what is our second term minus our first term, we'll get d. So then what is our third term? Take away our second term. So in this case, it's 3 minus 3 over 2, which you could use a calculator for. And guess what? You get 3 over 2. And now, let me check the next one. I'm going to go term number 4, take away term number 3, which is 9 over 2, take away 3, and I used my calculator again, and I got 3 over 2. So the moment it comes to something where it's not easy to kind of see the difference, don't forget that you can just say the next term minus the one before. So this is arithmetic, so I can write down my formula. It's a plus n minus 1d. A stands for my first term, which in this case is 0. N minus 1 have to remain, and my difference is 3 over 2. So if I neaten this up a little bit, I actually get 3 over 2 times n minus 1, or if you multiplied it out, which you don't have to, you'll get 3 over 2n minus 3 over 2. Again, you can put in 1 or 2 n values just to check if you're right. Okay, so hopefully we're feeling confident with identifying a linear pattern and then using the formula to find our Tn. So let's start making the questions just a little bit more complicated. So this question says, determine which term of the sequence, negative 4, 1, 6, is equal to 56. So this is a value of the term. Now, if it's a value of the term, it will be some Tn. I don't know what position, so I don't know what n is, but it's a value of the term. So let's look at our sequence. How do I get from negative 4 to 1? I'm adding 5 each time. So absolutely this is linear. So my formula is a plus n minus 1d, given to you on your formula sheet. So Tn is equal to negative 4 plus n minus 1 times 5. Now you can simplify that if you want to. So or you could multiply out, in which case you'd get 5n minus 5 minus 4. So that's minus 9. So both of those are acceptable. Now it says which term equals 56. Now it doesn't say the 56th position. It says which term is equal to. So my value of my term is 56. So my Tn is 56. and they want to know which term is this. So what position is this? So either you can substitute it into there or into there. It depends on what you want. If I was doing the first one, I'd now probably add 4 to both sides. So let me erase that. So I'd probably add 4 to both sides and get 60. So that minus 4 is gone. And then it's 5n minus 5 if I multiply this out. If I add 5 to both sides, I get 65. And if I divide by 5, I get 13. So basically, the term in the 13th position has a value of 65. If I was doing it on the other side, I would have added 9 to both sides, and you just get there a little bit faster because you've already done some working out. So again, the value of the term in the 13th position is equal to 56. Okay, these are my favorite of the questions in patterns. It says, given that T4 is equal to 13 and T12 equals 37, determine the general term of the sequence. Now this seems like really complicated and I don't know lots of things, and I always draw myself a picture. Term number 1, term number 2, term number 3, term 4, 5, 6, 7, 8, 9, 10, 11, 12. So what do I know? I don't know term 1, term 2, term 3. I do know term 4. 5, 6, 7, 8, 9, 10, 11. And I do know 12. Now, I find it easiest to draw myself a picture because then I can say to myself, well, how do I go from 13 to 37? Well, if this is a linear pattern, which I should have actually mentioned, but it is, if I'm adding d every time, and I keep going, so I should have actually said in the question, they are a linear pattern, because they actually would have to tell you in this case, plus d, and finally plus d. So my question is, how many d's did you add? 1, 2, 3, 4, 5, 6, 7, 8. Now that makes complete sense, because to go from 4 to 12, that's 8 places higher. So it would make sense for me to say that 13 plus 8 sets of differences will give me 37. So I don't have to do a simultaneous equation or anything funny here. The question is, can I figure out the difference? And I can, because I've just made myself a little equation. 13 plus 8 differences will get me 37. So if I minus 13 on both sides, so what's the difference between 37 and 13? I get 24. Now that makes sense because I'm clearly adding 24 here, and that 24 has to represent 8 differences. So if I divide by 8, I get 3. So it kind of makes logical sense. Now I need A. Now I could kind of work backwards, but it would be much easier just to fill in my picture. So what would I have to add to 3 to get to 13? That's 10. So I'm actually kind of going backwards, so I'm minusing 3. So that would have to be 7, because 7 plus 3 of 10, which means this is 4. So therefore, I didn't do much working to find A, but I know the formula is 4 plus n minus 1 times 3. Again, you could multiply that out and make it a little bit neater, but there's nothing wrong with that. Okay, now what happens if it was too far? What happens if they'd given you term number 100 and now you had to work all the way back to term number 1? That's a little bit tricky. So if you know the difference is 3, and in this case I know that T4 is 13, I could have actually used an equation to solve for A, because I could say, well, 13 is the value of the term with A plus 4 minus 1 differences of 3. So this is just Tn. So the fourth term has a value of 13. Is A, I don't know, plus n minus 1 times the difference. So then I say 13 is A plus 3 times 3 is 9. And if I minus 9 on both sides, I get 4. Now, I definitely wouldn't use this method in blue because it was so much easier just to hop backwards on my picture. But I'm just showing you that in case you're working with term number 300 or something big, and then it's not really practical to hop backwards. Right, let's try another one similar to that. Given that T7 is equal to negative 28 and T15 is negative 68, determine T20. So same type of idea. So there's term 1, 2, 3, 4, 5, 6, 7. So this is minus 28. 8, 9, 10, 11, 12, 13, 14, 15 is negative 68. So how many times would I have to add a d? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 differences between these two terms. Now again, that makes sense because I'm going from position 7 to position 15. So when you start getting good at this, you start now having to not draw the pictures because it's obvious that you're adding 8 differences. So if I make myself a little equation, so negative 28 plus 8 differences is going to get me to negative 68. So I'm assuming d is going to be negative because I'm clearly getting smaller. So if I add 28 to both sides, I get negative 40. And if I divide by 8, I get negative 5. So my difference is negative 5. Now this question asked for t20. So my question is, can I just keep going? 1, 2, 3, 4, 5. If I know that the 15th term is negative 68, so if t15 is equal to negative 68, won't t20 be negative 68 plus 5 differences? And so won't it be negative 68 plus 5 times negative 5? So it's actually minus 25, which I think is minus 93. So that's one way to do it. You don't always have to use a formula. We could have found the formula and then found the 20th term, but it was easier just to think, well, if we're at term 15, let's just keep hopping on. Right, let's look at 2 more. Given the sequence 25, 19, 13, 7, what is the position of the first term that is less than minus 100? Now, the beauty of a question like this is, if you didn't know how to do it, couldn't I just keep on writing out terms until I got below minus 100? And absolutely, as long as you show you're working, you can do that. Let's try and use a formula. So I see that I'm subtracting 6 there, I'm subtracting 6 there, and I'm subtracting 6 there. So this is a linear or arithmetic pattern, which means the formula given to me is a plus n minus 1d. So in this case, my a value is 25, and my difference is minus 6. Now, if I just neaten that up, because I'm going to have to work with this, so I might as well neaten it up. So it's minus 6n plus 6. So my nth term, if I've neatened it up, is minus 6n plus 31. Now, they want to know from me which term is less than minus 100. What's the first term? Because obviously there's lots of terms less than minus 100, but what's the first term less than minus 100? Now, they didn't tell me that minus 100 was actually a term in the sequence. So I don't know if it's going to be a term in the sequence, but let's put it in and check. When would this pattern get down to minus 100? So negative 6n plus 31. If I minus 31 on both sides, I get that. And if I divide by n, now you'll notice that n can never be negative because n is a position. So if you get a negative n, you know you've done something wrong. So I get position number 21,83. Now I'm just going to write myself a note here. Positions cannot be negative, and positions can also not be fractions. Now, this is a fraction. So what's going on there? So I need to clarify this. Positions cannot be fractions if that number is a term in the sequence. Because you can't possibly have position number 21.83. But remember I said I didn't know whether negative 100 was a number in the sequence. So positions cannot be fractions if that number is actually a term in the sequence. So what does this mean here? This means that negative 100 isn't actually an exact term. So maybe there's negative, 99, and then there's negative 105. So negative 100 isn't exactly a term in the sequence here. But it doesn't mean that I can't answer this question, because the question says, what is the position of the first term less than minus 100? Now these terms are going down, 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 further and further down. So somewhere here, we're now going to get less than minus 100. Obviously we won't get exactly minus 100 because we got a fraction, but somewhere. Now the n says 21,83. So what it means is term number 21 will be bigger than minus 100, and term number 22 is going to be less than minus 100, and I'm not actually ever going to equal minus 100. So I'm not rounding off here, because even if this was 21,1, even if this was 21,01, my answer would now be 22. Because the point is, you need to go beyond the 21st term to get below minus 100. And so term number 22 would be the first position to be less than minus 100. So just don't forget that if you get a fraction for n and it was meant to be a term in the sequence, you've done something wrong. But if you don't know if it's an actual term in the sequence, it doesn't mean you've done something wrong. It's quite tricky. Right, let's look at our last example for linear patterns. This question says 3x plus 1, 2x, and 3x minus 7 are the first three terms of a linear number pattern. Determine x. Now, the moment you see linear or arithmetic, alarm bells need to go off, and you need to say to yourself, I know about them because they have a constant difference. All linear or arithmetic patterns have a constant difference. Now, I can't work out my constant difference here to be an exact number because I don't know what x is. But can I find an expression for my constant difference? So this difference would be term number 2 minus term number 1. So if I just simplify that, that would be negative x minus 1. Remember, it's the second term minus the first term, and just don't forget that bracket. This difference would be 3x minus 7 minus 2x, which would simplify to x minus 7. So this is an expression for the difference between term number 2 and term number 3, and this is an expression for the difference between term number 1 and term number 2. Now the point is they have a constant difference, so my d's must equal each other. So this is a very common question. How I'm going to find x is I'm going to use the fact that these differences must be equal. So negative x minus 1 has to equal x minus 7. So if I bring my x's over, so I add x to both sides, add 7 to both sides, divide by 2, I get x is 3. So really, really common question, and we're going to do it again in quadratic patterns. The idea that if something's a linear or arithmetic number pattern, it's a constant difference. So if you can find an expression for the differences, you can equate them, which allows you to solve for x. Now what's wonderful is you can check, because I can just sub this in. So now my first term was 3 times x plus 1, which will be 10. My second term is 2x, which is 2 times 3, which will be 6. And then it's 3 times 3, which is 9, minus 7, which is 2. Now, does this form a linear number pattern? Yes, it does, because I'm subtracting 4 every time. Great, so that's the end of linear patterns. We've got an exercise that we're going to be able to practice this. Well done, guys.